data analysis is there. Now we will be talking of data analysis. I think this figure is telling you many things about the data analysis: variance, mean, cross-tab, stat, insights, skill, tools, categorical data, summarization, continuous variable, independent variable, deviation domains, dependent numeric, or all sorts of things are there. Some you might be knowing that, some you will like to know afterwards also. So gradually we will be building upon that. What is this data analysis? Particularly when we are talking of data analysis, let me remind you my earlier discussion, steps of research. I think well versed now you are with the steps of the research, that we are having problem definition, we are having research design. All these are interconnected. That's why I am again and again recalling all these steps. They are interconnected. That's why we say that research is a scientific process, research is a systematic process. If research is not a systematic process, all these steps are not as we are following one after the other. So keep in mind that after having identification of the problem, after having definition of the problem, we are deciding about the research design, what type of research we will be talking of, whether we are talking of experimental research, exploratory research, descriptive research, or different other types of research also, which so far you have understood. Then we talk of, this section is data collection section, wherein using appropriate tool, appropriate word is very important. What type of data you would like to collect will decide about the appropriateness of the tool. So depending upon the appropriateness of the tools which you have used, which you will be learning also afterwards today only. So using appropriate tool of data collection, we are collecting data. And that data, let me remind you that when we are talking of data, data can be collected from primary sources, data can be collected from secondary sources also. And another component, again entering into the data types, nature of the data, when we are collecting data whether from primary source or from secondary source, this nature of the data can be qualitative, maybe quantitative also. So basically, whenever we are in the process of the collection of data by way of using or applying appropriate tool, we are getting data, and that data may be nature wise, it can be quantitative, it can be expressed in terms of quantity, it can be qualitative also, which can be expressed in terms of non-numeric form. And then when we are having this whole data with us, we are in the process of data analysis. So data analysis, where it is, as far as the step of research methodology is concerned, as far as steps of research are concerned, data analysis is afterwards. Again, let me repeat, steps we have completed are data definition, data identification, objective formation, hypothesis formation, then deciding about the research design, and then collection of the data with the appropriate tool. And ultimately, now at this stage of data analysis, we have with us whether qualitative data or quantitative data. So one thing we have to keep in mind, data analysis basically is to be conducted given that we have qualitative or quantitative data with us. So up to this stage, we have already completed our research process. Now we are at the stage of analysis. And very important to keep in mind is that whenever we are having collection of the data, there may be two types of the data. Just now I told you, one is quantitative data, another one is qualitative data. So looking into the nature of the data, we enter into the process of data analysis. That is to be kept. Now question is, because today's topic is descriptive statistics, from where we are having, I am trying to link it with the data analysis. I am trying to link it with the nature of the data. So the moment we are having quantitative data or qualitative data, For the purpose of data analysis, again, let me tell you, we will be telling you what this data analysis gives us. But for that surety, one is to be kept in mind that quantitative data is with us. So statics is a tool for quantitative data analysis. This is to be keep kept in mind that whenever we are in the use of statistical analysis, we are trying to analyze that data which is in quantitative in nature. So quantitative data statistics to be used, statistical analysis is to be followed, and that's the basic requirement of the data. Now, let's see when one should call data as quantitative data and when one should call it as qualitative data. A little difference is there. Data that can be numerically analyzed and quantified into hard facts is coming under the category of quantitative data, and non-numeric data that describes qualities, opinions, or feelings. For example, if I say good, bad, shining, not shining, very good, all these are qualitative descriptions of the data. And when we are in the quantitative data, we mean to say numeric values are there, good, to what extent it is good. And let me clear at this point of time only that always whenever we talk of qualitative data. First, we are trying to have qualitative data. Why is this such a scientific? Because most of the time, whenever we are having qualitative data, because of its limitations, we try to transform the data into quantitative nature so that statistical applications are possible, so that scientific measurements are possible, accurate measurements are there. You will find that qualitative data is not having fine tuned descriptions of the fact. For example, again, the light is very good, the air ventilation in this room is appropriate. What all these terms are telling us, if we are not quantifying these terms, appropriate, good, very good, uh, smoothing, all these qualitative descriptions are further quantified into getting quantitative data. So for quantitative data, you will find collection methods are also different. That's why I said that appropriate qualitative tools are to be used for qualitative data. Appropriate quantitative tools are to be used for for quantitative data. So getting quantitative or qualitative data, again, we have to try by having appropriate data collection methods or the techniques or the tools. Both, we can't say that one is good over the other and quantitative is good and qualitative is good, but definitely we can say that quantitative data is best for drawing conclusions through large scale studies, conducting statistical analysis, and we all know that statistical analysis gives us more accurate results. But one of the flaw is that whatever quantitative data we are having, we are quantifying from our side. Heat is very high today. Heat is high. High means what? Or temperature is 23 degrees centigrade, 23-degree Fahrenheit, or 17-degree Fahrenheit. All these are numeric quantitative data when we say in terms of the quantity. So quantitative data is having its own weakness and strengths also. Qualitative data also is having its own strengths and weaknesses. Both are to be worked out simultaneously. And that's why nowadays, at this point only, let me refer to that that right now we are talking of quantitative as well as qualitative data. Sometimes quantitative data gets support from qualitative data. We are having triangulation technique also, that whatever quantitatively we have collected data from quantitative tools is to be triangulated into into quantity by way of qualitative consideration of the data. So both tools we are using, and we are triangulating either quantitative data or qualitative data from each other. That's the technique. And nowadays we are talking of mixed data. We are having to have good research, to have dependable research results. One should triangulate quantitative data with the help of qualitative data, or qualitative data with the help of quantitative data. So mixed type of researches are nowadays in the market. But definitely when we are
अनिल सर
talking,
फुल स्क्रीन कर लेना सर,
eh,
अनिल सर फुल स्क्रीन कर सकते हैं,
full
फुल स्क्रीन
screen
कर लीजिए
देखता
सर
हूँ.
प्रेजेंटेशन.
ओके, फुल स्क्रीन आ गया.
यस सर, यस सर, यस.
So best, we are talking of best when we are getting from quantitative data, when we are getting from qualitative data. Now coming to data analysis, definitely when we are having quantitative data, statistics is for our help. We are using statistical analysis techniques tools also for analyzing quantitative data. For qualitative analysis, we have different techniques like coding, decoding, content analysis, and so far so forth. I think this example again will help you in understanding the difference between quantitative and qualitative data. Let's read that. Did you buy ice cream today? Yes or no? This is quantitative conversion. When we say, why did you buy ice cream today? If our question is like that, then we are entering into the depth of that ice cream buying. So it is in qualitative form. And that's why data examples, again, if you look at, you will find percentage form, numeric form is there. So now, what is this data? Whether we are having quantitative data or qualitative data, what exactly this data is? What is the nature of the data? One thing you will assume, you will be able to explain that but whether we are talking of quantitative data or qualitative data, data is raw form of anything. So data is raw. It only refers to the collection of facts usually collected as a result of experience, observations, or experiments. I think those who are from engineering side, those who are from science side, and those who are from education side, they all might be understanding that you are many times we are collecting data which is a fact finding technique through result of experience. We are asking our teachers about your experience in classroom dealing. Observation, some observer is sitting back of the classroom and noting, observing different phenomena happening at that point of time in the classroom transaction by the teacher. Experiment, well versed with all of you, science subject is having experimental studies. Experimental means wherein we are manipulating the situation and we are trying to enter into the experimentation stage of the uh, data collection. So experiment is to be conducted. One is control group, another one is experimental group. Sometimes instead of having two groups, we only have one group, that is experimental group one. So anyhow, and we are manipulating some variable that experimental group, and ultimately by way of conducting experiment, we would like to see the effect of manipulation of that particular variable on the on something like, for example, I can say in education, we manipulate that teacher is teaching through ICT. Instead of traditional method, we manipulated that let teacher teach through ICT in the classroom, and we would like to see the effect of teaching ICT through ICT on achievement, on performance, on learning of the students in that particular course of time. So during that particular experiment, we are experimenting and we are trying to find out the effect impact of that on something, some other variable. And that's why there is concept of Again, in research, there is a concept of dependent variable, independent variable. So we, by way of experimenting, by way of conducting experiment, and experiment is nothing but manipulation of the facts. Something we are manipulating, which we would like to study the effect of on something. Data represents a fact or a statement of events without relation to other things. So please keep in mind, data is data only. It is having no relationship with any other aspect. It simply exists and no significance beyond its existence. And all this, you will find that data will give us nothing as far as research findings are concerned. Simple having data, simple having collection of data will not lead you to any results if you are not analyzing that data. So this is to be kept in mind. Likewise, there are so many peculiar aspects about data which one should know as a researcher, that data doesn't have meaning in itself. This may, I will clear this further. This may consist of numbers. If numeric data is there, this may be in form of numbers. This may be in form of words, images. If data is in, we have collected is qualitative data. So whether we have qualitative data or quantitative data, it is just a observation on a set of variables. And data, that's why, because of all these characteristics of the data, that it is raw, it doesn't have any meaning in itself, it doesn't tell us the relationship with the other existing variables. Because of all these facts, data is often viewed as lowest level of abstraction from which information and knowledge are. Very important aspect here is, data is to have meaning. To have meaning from the data, what we should do is, we should convert that data into information, and ultimately information is to be converted into the knowledge, and that is what we require when we are in the process of research. Data example, very crude example is, it is raining. Simply we have this data, it is raining. Now if you look at this example, it is raining, it doesn't give us but what type of raining is there, when it is rain is there, how much raining is there. It doesn't have any clue about that till we are saying it is raining. This is hard fact we have collected, we have observed from the environment, it is raining. Now to convert that hard fact, to convert that data into some meaningful findings, we have to we have to translate, we have to convert that data into information. This whole hierarchy we have, that data is raw data, this is raw, to be converted into information, which will be giving us some meaning of that joy. Because why it is giving us meaning? Because we are connecting, we are contextualizing that data, that it is raining, then how it is raining, and why it is raining, and where it is raining. So context is being provided, meaning is being provided. So we say that data we have converted into information, and this information is again having not all the varieties, all the findings which we would like to draw from there. So information, ultimately you all know that research, gaining new knowledge or advancing knowledge in the existing area. So no, for research, knowledge is required. So this again, data is to be converted into information, and information is to be converted into knowledge. And ultimately, sole purpose is that whatever data we have, by way of converting that into information and knowledge, we are trying to achieve wisdom in our life. And if you look at right side of that, दिस इज रॉ डेटा, मीनिंग प्रोवाइड किया, इंफॉर्मेशन हो गई, कंटेक्स्ट प्रोवाइड किया, नॉलेज हो गई, एंड अल्टीमेटली दिस इज हैपनिंग. Now what is information? Just to make you aware of, it is data that has been given meaning by way of relational connections. This meaning can be useful but doesn't have to be. Uh, Look at the example where it is raining. Now what we have did, the temperature dropped 15 degree and then it started raining. So data which was it is raining now converted into information by by way of having contextualization, by way of having relationship between that. The temperature dropped 15 degrees. That's why it is raining. So why it is raining? Now data we have given information that because temperature was dropped by 15 degrees, so it is started raining. So we reach to the level of information. Knowledge means you look at this. If humidity is very high and temperature drops, it started raining. So again, explanations are there. So look at the three: data, information, knowledge. Again, with the help of this diagram, I would like to show you. Now look at this data. Data is being represented by these characteristics. Now look here. What is the difference between data and information? Data was like that with no relational variables. Now we have interconnected these variables very finely. So data converted into information, and then we have tried to arrive at something findings by way of converting this information into knowledge. So look at these three diagrams. Independent, first one is independent, second one is related to, dependent also on some other variables, and this third one is showing you the connections, the detailed connection, the way to arrive at the knowledge. So looking at these diagrams amply clear, make it amply clear that what is data, what is information, and what is knowledge. Again, try to understand that डेटा की अगर हम कनेक्टेडनेस बढ़ा दें, यहां से हमारा क्वेश्चन होता है व्हाई डेटा एनालिसिस, व्हाई वी एंटर इनटू द प्रोसेस ऑफ डेटा एनालिसिस. वी एंटर इनटू द प्रोसेस ऑफ डेटा एनालिसिस by way of providing connectedness of the data to other things. For example, data is to be converted into information by way of understanding the relationship between two. It is raining. Why it is raining? Because temperature dropped. So relation we have established, and that's why from data we reach to information. When we are trying to understand the patterns, different patterns, again and again it is happening. It is raining because of drop in temperature. One time we have noticed, then another time we have noticed, third time we have noticed, and ultimately what we can say, we have developed a knowledge wherein we can say that yes, raining is because of drop in temperature and because of other aspects, contextual aspects also. So by way of understanding pattern, we move to knowledge from the information part. So again, I would request you, all of you, data is processed to become information. Rules are applied to become knowledge from the information. So pattern making is there. We reach to this stage. I think all of you are well versed that all scientific rules, phenomena, concepts are arrived at knowledge stage by way of having converting data into information. Again and again we are trying to experiment, and when we see pattern there, we see some kind of pattern, we try to understand, or we try to convert this information into knowledge part. And ultimately which is not the purpose of education, so I'm not discussing their wisdom, but definitely data ultimately lead to reaching at the top, that is understanding principles. So by way of understanding principles behind that knowledge, we try to develop wisdom which is beyond the limit of the education. So simply if we say what is data analysis help us in converting data into information, information into knowledge, and in knowledge into the wisdom part. And research is also extension of the knowledge, existing knowledge which we have right now. Research to an extent, maybe very small, maybe very minor extent it may be there, but definitely whenever in that particular area. So a bit of extension is there, a bit of addition is there in the existing knowledge, and that's why we say in research, data analysis is very much required. That is the purpose of the research. Then only we can say something, yes, we have added some kind of knowledge into the existing knowledge. We move beyond the existing knowledge, and that is what research is. To go into further details of the data analysis really help us in understanding data. We try to understand data by way of having data analysis. We are trying to make arriving at decisions by way of understanding data. So the purpose, the importance of statistics in data analysis is that statistics helps us in understanding data, making decisions reliably, validly, and then identifying relationship. I think correlations and all these are giving us relationship pattern, and then ultimately drawing conclusions about that particular phenomena which we have studied, maybe through experimental study or maybe through descriptive research also. So by way of having different designs of research, we are trying to understand the collected data. We are trying to make decisions by way of having whatever data we have collected. We are trying to identify relationship of whatever data we have, maybe some dependent variable, maybe some independent variable. And now data analysis by way of using statistical analysis, we are trying to identify the relationship between dependent and independent variable. And ultimately, the last part is that statistical analysis help us in drawing conclusions about that particular data, that we can conclude by way of saying this, that this is relationship between x variable and the y variable. Yes, now we are entering into that. So, with this much of the previous knowledge about the nature of data, the use of statistics and data analysis techniques, how it is helping and what way it is helping, now we are two types of statistics. If you again look at the statistical part, content of that statistics, you will find that there are two types of statistics. Very clear is one is descriptive statistics, wherein we are trying to describe the characteristics of the product, wherein we are trying to name those characteristics, wherein we are simply saying just describe whatever you have seen, whatever you have observed, whatever you have experienced there. That is descriptive, under the category of descriptive statistics. When we talk of inferential statistics, another type of statistics which we are talking of, that is when we are trying to draw conclusions on unknown processes parameter based on information contained in a sample. I think somebody mentioned about that, we have learned about sampling, population and sample relationship, etc., etc. So when we are studying, most of the time I would say research is working on samples. So when we are in the category of descriptive studies, if we are applying descriptive stat for the sample, we are simply getting what is there, what are the characteristics of the sample. But purpose is not why we are drawing samples. We are drawing samples from the population by way of making sample as representative sample. So ultimate purpose of research is not to remain up to samples, but to extend that whatever we have studied, whatever we have analyzed for the sample, extending that to the total population. And that's why we say that it is very necessary to have representative sample out of the population. Because here again, if you are not having representative sample, let me tell you, whatever inferential statics conclusions you are drawing based on the sample will be false, will not be that accurate which you wanted to be by way of having research. So friends, let me again repeat it. We have two types of statics. One is descriptive statics, another one is inferential statics. In descriptive statics, we describe what it is. Simply, we describe what it is without going into the sample population issues. If we are describing population characteristic, we say we describe total population. If we have described sample, we say that we have described the sample in totality. So simple, whatever you are seeing, whatever you are experiencing, whatever you are observing, if you are in the process of description in data analysis, we say we are applying descriptive statistics for the purpose. But when you are going beyond by way of studying characteristics of the sample, if you are extending that knowledge to your parameter, to your population, sorry, then you are in the application of inferential statistics. Inferential means we are drawing inferences based on sample about that population. So मैं बहुत सिंपल शब्दों में मैं कहूँ कि इन्फ्रेंशियल स्टैटिक्स का यूज वहां होता है जहां हमारे पास सैंपल की स्टडी के साथ हम एक्स्ट्रापोलेट करते हैं, इन्फ्रेंस ड्रॉ करते हैं अबाउट द टोटल पॉपुलेशन। और ये तभी होगा, मैं क्वेश्चन बार बार दे रहा हूँ, ये तभी पॉसिबल है, एक्यूरेसी इसकी तभी होगी, एप्रोप्रिएटनेस ऑफ द फाइंडिंग्स विल बी ओनली व्हेन यू आर हैविंग sample drawn as representative sample of the population. So descriptive statistics only describing characteristics of the data, whatever you have collected, simply describing. Inferential, based on that data you have collected in the form of sample, you are trying to achieve findings for your total population. That is inferential study. I have given you some of the examples here. Again, descriptive, inferential, look at. Descriptive situations are involving tabulating data, depicting data, and describing data. So, describing present situation about, that is descriptive stat, is a part of descriptive, and drawing inferences based on prediction, estimation of the characteristics of the population. Again, let me repeat it. सैंपल को स्टडी करके, सैंपल पर एनालिसिस फॉलो करके अगर टोटल पॉपुलेशन की बात करते हैं तो हम कहते हैं कि हम इन्फ्रेंशियल स्टैटिस्टिक्स का यूज कर रहे हैं। और सिंपली सैंपल है तो सैंपल, पॉपुलेशन है तो पॉपुलेशन, अगर उसको डिस्क्राइब कर रहे हैं तो हम कहते हैं हम डिस्क्रिप्टिव स्टडी। हाउ वी आर डूइंग दैट, हाउ स्टैटिस्टिक्स इज हेल्पिंग अस, वी विल सी in this. But keep in mind, whether you are having descriptive statistics or inferential statistics, in both these conditions, first of all, you think of whether whatever type of statistics we are applying for data analysis is appropriate, because there are assumptions and conditions about use of statistical method. So selection of appropriate statistics for data analysis depend on what assumptions you have to follow, what conditions of statistical method you have applied for. Example बहुत सिंपल से हैं, आप सब जानते हैं, you know very well, mean, median, mode and correlation and all these are under the category of descriptive statistics. अब देखिए, selection of appropriate statistics cannot be decided pre-hand in the research. हम प्लान करते हैं, रिसर्चर्स में कोशिश करते हैं कि हम कहें कि हम we will be using that, presuming that we will be here. So presumption is there, then only we can think of that yes, this will be appropriate. But actually, selection of appropriate, depends on, always depends on objective you try to measure by way of having data analysis. So what conclusions, inferences you will try to have when you are having objectives very clear in mind. Then another important aspect of use of descriptive statistics or parametric or non-parametric statistics is that you should be well aware of type and distribution of the data, whether your data is normally distributed or your data is abnormal. So whatever data you have collected, what is the nature of that, it also helps us in deciding appropriate statistics. And third one is nature of observation, very important. This is little critical aspect. This is little specific in statistics, that we have to identify that whatever wherein you are having two different groups of the two different groups of the subjects. So depending upon these three observation, broadly we can define, we can say that appropriate use of statistics will be when you have taken into consideration the type and distribution of the data, or you can say nature of the data used, or third one is nature of the observations, also whether these observations are taken in paired conditions or unpaired conditions. Sometimes you may find paired t-test, paired unpaired t-test. Sometimes you may say paired ANOVA, unpaired and ANOVA. So all these terms are to be kept in mind, that these three aspects, minimum these three aspects, there are many. If you go on minutely in the statistical part, statistical analysis, you will find number of assumptions, a number of conditions which you have to satisfy first. Then only you can apply that statistical analysis technique as appropriate one. And let me again repeat it. Let me again give you caution that until and unless you are not having these things in your mind, until and unless you are not keeping these things intact in your data analysis, you are likely to lead to unfair findings or inappropriate results. So, whatever results you are attaining by way of data analysis, you will be finding that they are not reliable and valid. So, first, before undertaking the task of data analysis, think of twice whether you have to use this stat or that stat, keeping in mind objective, type of distribution, and nature of observation. And that's why again in inferential study you find, which we'll be discussing with you afterwards, parametric and non-parametric concept are there. Now coming to statistics, descriptive statistics, I think need not to tell you all, you are all aware of the fact that when our focus is describing data, we are trying to have create frequency distribution. We are trying to have measure of central tendency. By way of having central tendency, we can describe data. By way of having measures of dispersion in our mind, we can think of describing data. Standard scores, I think nowadays there is much of the use of T scores, Z scores, all these are standard scores. I think UPSC examination and a lot of employment agencies are nowadays in the process of using standard scores. Why? Because they want to describe that data there. Normality, when your focus is to look at the nature of the available data, you enter into the process of normality, wherein normality is describing the existing data, whether it is, and describing in terms of normality of that data. It is particular type of curve. I will be discussing that. Description of the data can be in the form of correlation also. You say A variable is this, B variable is this, A variable data is here, B variable data is here, and by way of having correlation, you are simply describing the relationship of A variable with the B variable. So many descriptive statistics techniques are there. These are, and graphical representation is also one of the best way to visually describe the data. The only difference is here we are describing the data in tabular form or in visual form. So graphical representation is also considered as one of the descriptive statistics component, wherein we are describing the data by way of visualization, by way of table formation. I think frequency distribution, I will be moving little fast because I think all of you are well versed with that. From I think eighth standard onward we are studying all this. Descriptive statistics is in our use from the very childhood. So average we are always talking of, median we are always talking of, mode also we are talking of, and different type of pictorial diagrams also we have seen, we have observed in day-to-day life also. When we are opening a newspaper, daily newspaper, one type or other type of charts you will be finding there. But just to remind you, that to bring back to your mind, look at these data presented in picture. This is bar graph, this is histogram, this is pie chart, this is frequency polygon. Depending, again I would request you, depending upon the situation, what exactly you would like to have. For example, if your objective is to compare, simple comparison, you can think of comparison like of through this picture bar diagram. Histogram also you can think of, you can think of histogram with this part also. You can think of frequency polygon also. You can talk of again pie chart. The pie chart 360-degree divisions. Pie chart where when you are having full sphere, full circle, and circle divided into parts. 100% में से जब आपको पिक्चर दिखानी हो कि 20% ये 30% ये 40% ये, then we enter into the process of drawing pie chart. So these are very simple things. I think I am little. Frequency distribution can also be in ungrouped data, and frequency distribution can be in group data. So first we are having grouped and ungrouped data, then we try to have that here. This is, I think, from here onward we are. When we talk of measures of central tendency as it named, it is named there central tendency, यानी जो डेटा पूरे ग्रुप की सेंट्रल नेचर बताता है, सेंट्रल में क्या है, वो मेजर्स ऑफ सेंट्रल टेंडेंसी कहलाते हैं. And central tendencies basically, when we talk of, they are average, arithmetical average, or we call it as mean also, median, mode. And let me add one more word here, that when we are talking of, one minute, when we are talking of measures of central tendency, we try to divide them in mathematical average, wherein mean is there, positional average. These are measures of central tendency. Median and mode are measures of central tendency, but these are defining these things in positional average. So depending upon the position of that, they are defined. Depending upon mathematical average, they are defined. So mean is mathematical average, median and mode is positional average, but together mean, median and mode, all the three giving us measures of central tendency or average, where we are as far as the whole data is concerned, as far as central tendency, nature of the central tendency is concerned. When our concern is that to find out, to describe the data's central tendency, we try to use mean, median, and mode. And in mean also, you can think of arithmetic mean, geometric mean, harmonic mean. Normally in statistical analysis, we use arithmetic mean only. So I think I should not enter into simple calculations. Mean, you all know how to calculate. Again, I would say this is arithmetical average. So all values are to be added divided by total number of values. It will give you average or mean of that. But in case of median and mode, because it is positional central tendency, पोजीशन चेंज होगी, डेटा ऐड और सब्सट्रैक्ट होगा, तो हमारा मीडियन और मोड चेंज हो जाएगा. एंड दैट्स व्हाई वी से in all the three measures of central tendency, mean is the most stable aspect of average. Mean is the most permanent stable measures of central tendency. We compare mean with median or mode. Mode or median, they are positional. We have kept them in positional aspects also, because by changing, adding, subtracting data, cleaning of the data sometimes reduces the data, total data. So median and mode will change with the change of data, but mean will not change. If data is changing, if values are changing, mean will also change. So it is most stable measure of central tendency when we try to compare it with other measures of tendency, median and mode. And I think calculation also have that concept characteristics also, that median and mode is calculated by way of frequency, but mean is calculated by way of its each term's value aspect. So value is to be taken care of, how much heavy or how much unheavy that is their data. I think calculation part, you can read that. Mode फ्रीक्वेंटली अकरिंग स्कोर की बात करता है, मीडियन ग्रुप को डिवाइड करता है, हाफ हाफ लेफ्ट हाफ राइट, और मीन रिलायबल है, एक्यूरेट है, बेटर suited for arithmetic calculation. And that's why, that is the reason that mean is used in inferential statistics also, because it is the most stable measure of central tendency as compared to median and mode. It is frequently being used for inferential statistics, and in many of the advanced statistics you will find the use of mean. That is one of the permanent, one of the most stable measure of central tendency. It changes with the values, with the change in values, and that's why we say it is a stable value. Likewise, measures of dispersion, range, standard deviation, variance. These are the three measures of dispersion. Dispersion means how group is apart from each other, how elements of the group are apart from each other. When our purpose, our focus is to have the homogeneity or heterogeneity of the elements of the group, how this group is homogeneous, how much this group is heterogeneous. When our focus is on that measurement, description of the group in the form of homogeneity and heterogeneity, measures of dispersions are to be taken into consideration for analysis. So data analysis, use of descriptive stat helps us in deciding about the nature of the group, that how much this group is heterogeneous, how much this group is homogeneous. Standard deviation and variance, you all know the relationship, it is one of the square of the other. So range is very clear. Range means wherein you are simply saying minimum score or maximum score. What is the range of that? So it all the three measures, really speaking, provided the distance between the elements of the group, distance between individuals of the group. Look at range, very clear. Range is 22. मिनिमम स्कोर उठाया, मैक्सिमम स्कोर उठाया, सब्सट्रैक्ट कर दिया, रेंज विल बी देयर कैलकुलेशन. variance scores, individual scores in the distribution of score differ from one another. And standard deviation is nothing but a square root of the variance. So the variance or standard deviations are more or less same thing, but put it in different form. When your focus is to see that square root of the variance, you are in the process of standard deviation calculation. When your focus is on variance, you would like to see that how much distribution of scores is different from one another. So to be kept in mind is whenever we are in the process of statistical analysis, by way of measures of variability, we try to describe the particular characteristic, the characteristic of that particular group, that how far apart or how close each individual is there as far as their distance is concerned. Homogeneity, in other words, I can say, if our focus is to know the nature of the group in the form of homogeneity or heterogeneity, we are conducting data analysis, and that data analysis appropriate angle is measures of variability. Standard scores, Z score and T scores. क्या टाइम हो गया है? Can anybody remind me the time?
Anilji, no issue with the time. Please continue. No issue. It is now
Uh,
11:10.
Okay. So I will try to do. Now coming to the standard scores, two important standard scores we would like to have a discussion. Z score, most widely used standard scores in statistics. And Z number of standard deviation. So it is number of standard deviation above or below the mean. Z score looks at the position where from with respect to the mean, that how much standard deviation this number is away from mean. It is giving us Z value. Z, just take one example. If let's say we have Z score of 1.5, what does it signifies? It means that the score is 1.5 standard deviation above the mean. So plus minus value is there. If we say Z score of minus 1.5, we say score, whatever score we are talking of, it is 1.5 standard deviation below the mean. So Z score can be positive as well as negative also. Minus means below and plus means above the mean. That, so it is telling us the relative position of that particular number with respect to mean of the group. So mean is measures of central tendency. So how, so measures of central tendency के ये particular score कितना SD standard deviation above या below है. If our focus is on this, then we are in the process of calculating Z score. Again, I would say appropriate use, if we are talking of Z score, appropriate use means when one should use Z scores. When our focus is to see the relative position of a particular score with respect to the mean, we are in the process of calculation of the Z score. Second most common standard score is T score. Most commonly used standard score for reporting performance, T value. और ये जेड से फ्रॉम जेड से कन्वर्ट किया जा सकता है, एंड ऑलवेज राउंडेड टू द टू फिगर्स, देयरफॉर एलिमिनेटिंग डेसिमल. As we have seen that Z score may be in terms of positive or negative, but here in T score it is the quality of the T score, that is, it is always reported in positive numbers. The mean is always 50 and standard deviation is 10. So by assuming standard deviation of the 10 and mean of the 50, we calculate T value. And that's why we say 50 plus multiplied by 10, that is value. That is the T score. अगर थोड़ा सा जो है ध्यान दें, एनालाइज करने की कोशिश करें, तो आई ट्राई टू पुट अप all standard scores in that, and this is, I think, well known to all of you. Normal curve little bit I will be explaining you at the later stage, but if you look at that, standard scores are also linked to the normality of the distribution. This part is giving us in normal curve, this part is mean, median, mode, both the three lies at the same point. This is giving you the area 3.4%. This is 13.4. So this part is 13.59. This part is equal. And central point, say this distance and that distance is equal. Then only that it is normally distributed score. And this x-axis is defined in terms of sigma value, that is standard deviation format. This is mean, say, by standard deviation कम, mean से one standard deviation ज़्यादा, mean से two standard deviation कम, mean से two standard deviation ज़्यादा. So this percentage is showing that within this it is 34% of cases like. Likewise, there is 44 is always positive. Then another important descriptive statistics is correlation or covariation. I think all of you must be well aware of that. Many times we are having correlation. Correlations means just look at, it is telling you the relationship or association of the two variables. It is not relationship. It is not correlate with that. It is relationship and association, how these two variables are related to each other. So correlation coefficient gives us then a statistical summary about the magnitude as well as direction. Why we say magnitude? Magnitude is quantity. Direction means positive or negative. So correlation can be, coefficient of correlation can be in positive, in negative also. Both things signify something differently. That there is negative correlation, there is positive correlation. I think all of you are well aware of that. It is possible to have negative or positive correlation. Yes. Linear regression prediction also you are well aware of. By way of having knowledge of simple observation relationship, we can predict, we can have regression equation also for prediction purposes. देखिए, this is what I have shown you, normal curve. Normal curve means wherein we are having one mode only. As already I have told you, normal probability curve ki one of the important characteristic is, if data is distributed in normal curve, then it means that mean, median, mode, all the three measures of central tendency will lie on the same point, that is this point. But if data is having two modes, then it is not normal, it is abnormal, and it is bimodal curve. We call it as a bimodal because two modes are there. You can see from this diagram very well. Here one mode is there, here two mode is there, and that's why modal curve. It is not normal curve, it is bimodal curve. And this one is normal curve. Likewise, very important to know is why we are having normal curve. Normal means data is spread normally very well. Many of the inferential statistics part we use once proving or disproving that what nature of data is there. If data is normally distributed, we used to have inferential statics, one type of inferential static, that is parametric. If data is either positively skewed like this, positively, if you draw a line here, you will find this cutting here, and mean median mode will not apply on the same point. It will lie on the same point. Like if you see this is on right side, this. So left side scores are right side to spread. Score are left side spread. So whenever we are in the process of data analysis, think of about the nature of data. Take into consideration that scores are normally distributed. If not normally distributed, appropriate statics will change. Maybe non-parametric statics, which I will be discussing with you later on. But always try to decide about nature of the collected data which you have collected with the help of your instruments, with the help of your own design. So whenever we are in the process of research, data analysis is to be performed. Minimum requirement is, let's see first the nature of data as far as normality is concerned. Skewed normal distribution may, and normality is decided by skewness and kurtosis value. And normally in normal distribution, kurtosis is like this. Value is always, skewness value is 0 and kurtosis is 0.263. If there is variation either on left side or on right side, we will say data is not normal. Kurtosis values are differing. So by way of having calculation of that, we think of calculating kurtosis, skewness, and we designate that particular nature of the data according to the value of the skewness and kurtosis. Then another descriptive stat part is very important part is, and in our use also, in day-to-day use also, that is correlation. Many times we think of data analysis that let's apply correlation. Correlation means, again I would repeat it, measures of relationship or measures of association. And it varies from -1 to +1. Minus value is also there, plus value is also there. You all know very well. And correlation coefficient can never be more than 1. So it is defined in terms of less than 1 values only. आई थिंक दो मेथड्स कोरिलेशन के बहुत कॉमनली यूज होते हैं, जिसमें कहते हैं वन इज पियर्सन्स प्रोडक्ट मूवमेंट कोरिलेशन. It is used when we are in the domain of parametric statistics, and when our data is not normal, we use. There is another term also, measures of level of measurement. So rank difference correlation is applicable only when data is available in the form of ranks only. Here data is available in the form of scores, x value, y value available in scores, and we try to correlate x with y by way of having correlation between the scores of the x and correlation between the scores of the y. Rank difference, that is named as Spearman's rank correlation coefficient. Besides that, we have partial correlation, time correlation, tau rank correlation coefficient, Candles ने दिया था, confounding variables also. We are having a scatter diagram also. Many type of correlations are there. Again, pick up appropriate suitable correlation method for our purpose. Again, depends on the nature of data, whether data is in rank form, data is in a score form, or data is in some other form. Depending upon that, we decide about the correlation, whether to use Pearson's product movement correlation or whether to use rank difference correlation. Both are most popular coefficient of correlation method calculation. This is what I wanted to tell you. I think this is very basic, because let me again repeat it. When given data, requirement is that we have to arrive at some decisions and finding based on description of that data. We think of applying descriptive state to our data. But when data, we would like to go beyond that. Whatever sample characteristics are there, based on that sample characteristic, based on that descriptive state of that sample, we try to focus on population characteristic. We try to find out the relationship of the uh, sample and population. Based on that, then we are entering into the domain of inferential static. That is the part.